We saw that the dot product of two vectors creates a scalar by adding products of corresponding components. The cross product of two vectors in 3D is going to be a vector, however, so the cross product will require this x, and it ends up being this determinant, which is why we looked at determinants the last time. So the cross product is only defined for 3D vectors. Let's look at this example. 2, negative 1, 1, and the vector negative 3, 4, 5. Let's find the cross product. So we'll just set up according to this. First row is ijk. I know it looks a little strange to stick vectors in as the entries of a determinant of a matrix, but we'll do it. And then the entries of the first vector are here, 2, negative 1, 1, and the components of the next vector are there. And then we'll just compute according to that determinant formula we saw yesterday. So take the entry in the upper, so the things in the first row show up here, I, J, K, and then with alternating signs plus, minus, plus. So that's why there's a minus in front of the J. And then hiding the first row always. So how do we create these 2 by 2 determinants? As a reminder, hide the first row. If you hide the first column, you'd have this. If you hide the middle column, you'd have that. And if you hide the last column, you'd have this here. And won't work through the 2 by 2 determinants that appear here, but in the end you'll have negative 9i minus 13j plus 5k, and you could also, of course, write this in its angle bracket format. So the previous question, we took these two vectors in 3D and we got as the result of the cross product this new vector in 3D, which was negative 9, negative 13, 5 in angle brackets. Now, let's define u and v as before, and we will define w to be the result of the cross product. I'd like to find w dot u and w dot v. So w dot u, following the dot product formula, gives you the scalar 0, and w dot v, following the dot product formula, gives you the scalar 0 as well. Wait a second. Interactive question, go answer this. Answer this. We just took the vector resulting from the cross product of two vectors and found that some dot products are 0. What does this mean geometrically?